Good day, guys. Welcome back. This is Great Mind. If you have not subscribed, please don't fail to do so. Today we are looking at normal distribution, a course in statistics. Now we'll be dealing with data from large population, from small population. We'll be looking at them and how they are distributed. Now, when we say normal distribution, what do we mean? Okay, we mean data that are distributed in no particular order. They are just distributed around, randomly distributed in no particular order. Now, with the normal distribution, we'll be taking normally distributed data. We'll be looking at the normal distribution curve. Now, this normally distributed data, taking them together and putting them under a certain curve. Now, we'll be using their mean, their standard deviation, from the mean. Okay, so we'll be looking at the normal distribution curve. Looking at the normal distribution curve, which is in this way. Have the normal distribution curve in this form. Okay, and with a peak, let's do the diagram wall. A certain peak. Alright. So this normal distribution curve, this way, let's put this over here. Okay, so we're solving problems, normally distributed problems. To make it easier for us to solve, we'll be using the normal distribution curve. Now, the normal distribution curve is a curve in which we can take all the data, put it in it. Now, the mean lies at the peak. The mean of the whole data, the mean will take the normal distribution curve. The mean of the data we are given from the population lies at the center, at the peak of the normal distribution curve. So the line drawn from the peak divides the curve into two. So from the peak, divide the curve into two. So this is the mean. Okay, and one property of the normal distribution curve is that the central tendency, the measure of central tendency, all lie at the same point, which is at the peak. So you have the mean, the mode, the median, all lying at this point. Okay, so now we say the mean is at the peak. Okay, so now the data, we say we are bringing them and putting them all into the curve. Okay, so where the 65 will be, where the 61 will be, where the 54 will be, and where the 62 will be, the 10 will be dependent on the standard deviation from the mean. So the standard deviation of 54 from the mean will determine where the 54 will be. Okay, so assuming you have randomly distributed data, normally distributed data. Let's say we have normally distributed data. Have let's take 5, let's take 4, let's take 6. Let's take, okay, let's make it 5. Let's make it 4. Take 5. Take 6. Okay, have 4, we have 5, we have 6. So assuming you have 3 data this way, we say they are normally distributed. I'd like to explain what we mean. Now, the mean of these 3 data we know can be calculated by saying 4 plus 5 plus 6 divided by 3. Now, this is 9, this is 15. 15 divided by 3, this is 5. Okay, so you have the mean 5. Okay, so let's say the mean, if the mean is at the center, now where the 6 will be in, where the 4 will appear, depends on the deviation from the mean. Okay, so the deviation of the 4 from the mean is 5, which is the mean, is 4 minus 5, which is the mean. So you have the deviation to be negative 1. Okay, the 4 is less than the mean, so you have 4 being here. So here you have negative 1. So this is just to give the idea of how the numbers, the data are distributed under the normal distribution curve. Alright? But because we have different data, we have a lot of data in the world, we're dealing with questions having different data. They have mathematicians or statistics people have come out with a standardized normal distribution curve. they've come out with the standardized normal distribution curve. And for the standardized normal distribution curve, it is a curve, a normal distribution curve, in which the mean has been zeroed. So you have a normal distribution curve in which the mean has been zeroed. So the mean has been zeroed. Okay, the mean has been zeroed, and the standard deviation is 1. So standardized normal distribution curve is a normal distribution curve in which the mean has been zeroed and the standard deviation is 1. Okay, so the standard deviation from the mean is 1. All right, you have so the mean is 0. Now deviation from the mean, the whole deviation from the mean, this and this will be 1. Okay, so if this is 0, then you can have going this way, you can have deviating, you have 0.5, you can have -1. If you keep going, you can have minus. So values at the left side of the mean are lesser than the mean, so they have negative. They are negative value, so their standard deviations are negative, or their deviation from the mean are negative. And values at the right side of the mean, values at this side of the mean, yes, they are higher than the mean, so they are positive. So you can have positive 0.5, can have positive 1, and go and on. All right. So now we'll be using Z. We'll be looking at what we call the Z-score. Looking at what we call the Z-score. The Z-score. Looking at what we call the Z-score. Now for the Z-score, we are also, it's just like the normal distribution curve. Now for the standardized normal distribution curve, the values or the data in the standard deviation from the mean, the data in here are denoted. We denote them with the Z-score. Okay, so the Z-score you can also define as data having mean of 0 and standard deviation of 1. Let's not forget that the data in here, we know them with Z-score. All right, and again, lastly, what we have to know about normal distribution curve before we start solving question is that the probability of the numbers or all the data in the normal distribution curve, the probability for a data occurring if a random sampling or a random picking should be done, if a random picking should be done on the whole data that is put under the normal distribution curve, the probability for a data to occur, the total probability for the whole data to occur is 1. So the total probability for the data to occur is 1, and it's the same as the area under the normal curve. I'll take it again. The total probability for any data chosen randomly to occur under the normal distribution curve, the data you put there, the probability for any of them to occur is the total thing occurring is 100. Okay, 100%. For the total thing occurring is 100%, and it is the same as the area under the normal curve. So the area under the normal curve is the same as the probability of the data within the area occurring. Same as the probability of data within the area occurring. So taking note of that. So the Z-score mathematically is given by our Z-score given by, now the data you are looking at, the data you want to find its Z-score. The data you want to find its Z-score minus the mean of the data divided by the population's standard deviation. So you have Z, this is the Z-score. Now this S represents the data in which you want to find its Z-score, and mu here represents the mean of the data you want to find its Z-score, or the mean of the whole data, the whole sample of data you have, and the one here represents The rho here represents the population's standard deviation. So at this point, we start taking questions so we can see how the real thing is. Let's take an example and see how we can solve problems, normally distributed problems. So I can solve normally distributed problems. Now the first question I would like us to take is this. Now, the following data on bet of calves in kg were recorded for Ndama breed of cattle. Full stop. If the data is assumed, under S here, assumed to be distributed normally, determine the probability that, calves bet weight will fall from 16 kg. Alright, now I have a question. Say the following data on bet weight of calves were recorded for Ndama breed of cattle. They say if the data is assumed to be distributed normally, determine the probability that calf bet weight will fall between 16 and 22 kg. So we have the data given below: 17.5, have 15.9, have 15.2, have 18.8, have 15.0, 20.5, 21.9, 23.4, 23.4, 15.3, 24.8, 17.9, 22.7. So this is the data given below, the data of the bet weight of the calves. Now we have to find the probability that the bet weight of a cow will fall between 16 to 22 kg. Now remember, they said the data were normally distributed. Now because we should say the data were normally distributed, I'm going to wipe out this. Now remember, whenever we are dealing with normal distribution, to solve any problem, we first of all find the z-score to have our normal distribution curve. We have the mean, Remember we said the area under the curve is the same as the probability of data occurring on that at that given area. Probability of data occurring on that given at a given place is the area under the curve at that given place. Okay, so we have the data. Now these are mean. Don't forget these are mean. Our mean is at this point. Okay. Now we are to calculate. I remember we said that the value, the data that will come here, these are mean. We are zeroing it, and these data here, for them to be in here, we have to find their z-score. It is the z-score that we find in here. So we find the z-score of 16, even though 16 is not here, but we assume that it's a large population, and 16 and 22 are part of the population, but this is just a sample that was chosen from the population. Okay, so we have 16, find the z-score of 16, find the z-score of 22. Okay, so we have z-score, and that we said is z equal to the data we are looking for is z-score minus the mean of the sample divided by the population's standard deviation. So this is the mean of the sample, this is the data we want to find, is z-score population standard deviation of what you've taken. Alright? So now remember in our previous studies, our previous lectures, the mean is given by the sum of the x's divided by the number of occurrence, the number of observations. Now if you should impute, sum all this and divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 data. If you should compute the mean, you'll be getting 19.075. So if you should compute the mean, sum of the individual values divided by the number of values you have, the number of data you have, which is 12, you get 19.05. So have our mean to be 19.05. So now, so we have our mean, we have the data, so we have to find the population standard deviation, and it is given by population standard deviation from our previous lectures. If you recall, given by summation the s squared minus by summation of s all in bracket squared divided by n all over n. Okay, now this is square root. So our population standard deviation is given by this, right? So if you should compute it, you can use, remember our last lecture we looked at how to use calculator to compute summation s squared, summation x. So if you do that, you have this, just put in the values, find the summation of the squares of the value you obtain. 10, 4, 5, 0.79 minus 22 minus 22, 228.9 all squared divided by 12. Okay? All divided by 12. So if you should compute this, we'll be getting 3.348. Compute this, you get 3.348. Then so we have our population standard deviation. We have our mean, so we can put it in here to find the z-score of the system. So put it in here, you have the z-score of the system, which is, so you have z equal to our mean, so you have the 16 minus 19.07075 divided by 3.348. 348. So when we do that, we'll be getting minus 0.92 kg. So you have, so the z-score of the 16 is, z-score of 16 is this, minus 0.92 kg. So remember we said that the mean has been 0, and when it is negative, that means the data is smaller than the mean. So it goes at the left side of the mean. Data smaller than the mean. So this way is positive, this way is negative. So we have it somewhere. Let's put it here. We go 0. Have minus 0.92 somewhere, right? So that's the z-score. So 0.92. Okay, so if this to be distributed, the 16 value will be somewhere here, minus 0.92. Alright, so let's go and find the z-score of 22. So you have 22, z-score of 22, have z equal to 22 minus 19.075 divided by 3.348. If you should work out this with the calculator, you'll be obtaining 0.87. Work it out with the calculator, you obtain 0.87. And it's positive. Take note of the sign. Always let's take note of the sign. It's positive. The first one was negative, so it fell. It meant that the value fell at the left side of the mean. So now we are getting positive. That means the value is higher than the mean. So the actual data was higher than the mean. So it fell at this place. And if you take a closer look, the actual data was 22 and our mean is 19. So it's higher than the mean. So you have it this way. It's somewhere 0.87. So 22 in the normal distribution curve will fall somewhere there. Alright. Now we have found the z-scores. But remember the question said find the probability that a curve will fall between 16 and 22. A curve will fall between 16 and 22. And remember we said that the probability is the same as the area under the curve at that point. So we have to find the area under the curve. Find the area between 16 and 22. So let's say we have 22, we have 16. How to find the areas, right? So remember we said that the z-score for the 16 is minus 0. For the 16 we said the z-score 0.92, and here for the 22, remember the z-score we calculated to be 0.87. Now let's go. We have a table. We have a standardized table that is used to rate the area under the normal curve. So use the z-score to find the area under the normal curve. Let's go. So this is a standardized table. So we are interested to find the area 0.92. The first z-score we are going to look at is 0.92. The area is fall on 0.92. Now let's take a close look at our normal distribution, area under normal distribution curve. So we have our z-score to be 0.92. So we have 0.92. So this at this column we have values ranging from 0.1 to 3.0, and this column we have values ranging from 0.00 to 0.09. So take our 0.9 here, so we have 0.9 at this point. Then go up there, we have 0.92, I have 0.02. When you add 0.9 and 0.02, you get 0.92. So trace down this column, go down this column. Now 0.92 corresponds to area 0.3212. Area 0.3212. So you have 0.3212 correspond to that area. And the next one we are going to look at is 0.87. That's our next z-score for the 22. So we come here again, 0.87. Now remember this read from 0.00 to 3.0, so we can get 0.8 at this column. So 0.8 is right here. Have 0.8. Now trace it, 0.87. Look for 0.07 here. 0.8 and 0.07 will give you 0.87. So you have trace it to where you have 0.07 on top. So 0.8. Trace. I hope you can see that clear. You have 0.3078. So you have 0.3078 over here. 0.3078. 0.3078. Remember, this is at the left of the mean, so we have this to be negative, and this at the right of the mean, you have this to be positive. Good. So now these are the extreme areas for 16 kg. We have this 22, you have this. So now we are interested in finding the area between them. Now these are the extremes. These are the limits, the minimum and the maximum. So we have to find this area between 16 and 22. And we are saying the extremes from here to here, the extremes we have negative 0.3212, okay, and here we have 0.30. Let me check that again to be sure we're taking the right values, the right readings. Let me check it out again to be sure we're taking the right values. Alright, okay, we are taking the right values. Okay, so 0.03078. Okay, now these are the extreme areas. Now to find the remember this negative and this positive. Now to find this, just this. Remember when you have two ranges, to find the distance between two of them, we're supposed to do the one here minus the one here. This minus this will give us the extreme between two of this, right? So we have 0.3078 minus negative 0.3212. So you have 0.307 minus negative 0.3. Remember why we did this? We had to find just this area, and we have from this to this to be 16, half from this to this to be 20, we have here to be 22, and to find this extreme and subtract this and this. Alright, so then get 0.3078 plus 0.3212. So when you add these two things, you'll be getting 10, so after summing them up, 0.629. Obtain 0.629. Now 0.629 becomes the probability. So this whole area that we have marked is 0.629. So the probability that a data or the bet weight of a calf will fall between 16 to 20 and 22 kg lies between this area. So anything below 16 will not come in, and anything above 22 will not come in. And this area from our calculation is 0.629. And remember we said that the area is the same as the probability that a data will occur at a given place is the area of that area of that place under the normal curve. So have the 0.629 to be the probability that a bet weight curve will fall between 16 and 22. So we'll take another question, and that will be it for today. Now the second question we are going to take, now we have another scenario. So suppose that An animal breeder wants to set a growth rate guarantee for a newly developed strain of local broilers. Initial growth rate reviews a mean growth rate of 19.5 per day, with a standard deviation of 5.2 gram and a normal distribution. The breeder wants to set a minimum guaranteed growth rate such that not more than 5% of the bird performs less. Alright? So what minimum growth rate should the breeder announce? I take the question again. Suppose that an animal breeder wants to set a minimum growth rate guarantee for a newly developed strain of local broilers. Initial growth traits review a mean growth of 19.50 per day, with a standard deviation of 5.2 gram and a normal distribution. The breeder wants to set a minimum guaranteed growth rate such that not more than 5% of the bird performs less. So what minimum growth rate should the breeder announce? Now, in cases like this, you have a normal distribution curve. To draw that, we'll have a normal distribution curve. Now they said a farmer wants to find a minimum growth rate for breeder. Okay, and remember this is 0. Now we say the whole thing is 100%, so that means, and this is the center, so from here to this point, from here to this point, 0.5 or 50% or 0.5, and from here to this point is also 0.5 or 50%. The only difference is that this is negative, this side is negative, and this side is positive. Alright? So the farmer wants to find a minimum, wants to set a minimum guaranteed growth rate, such that not more than 5% should perform less. Now we are looking for a minimum growth rate. Now going this way, remember it's positive, you are going high, maximum. Now coming back, you are coming to the minimum data you have. So minimum growth rate not less than, in such that not more than 5% should perform less. So you have minimum, so our minimum is at this point, but we are looking for not more than 5%. So from here, this point to this point, let's say it's 5%. So we are doing it from here to here, not more than 5%. So not more than 5%, so everything here will perform less. But from here going, will not perform less, not more than 5%. Alright? So if this is 5%, now we are interested in finding what is this area? What is the area here? And what area do we have here? Alright? Now remember, we already said that from here, from this point to this point, that's from the end to the half of the mean, to the mean is half, is 0.5. And from this point to this point also is also half of the normal distribution curve, and that is 0.5. The area there is 0.5. Okay? And now we are having 5% here. We are interested in finding the area. We are interested in finding the area between here. We are interested in finding the minimum value that he should set. So this point here, right here, what area between here and going? So minimum area from here, the minimum extreme. We want to get the minimum extreme that he shouldn't set less than. So we need a guarantee that he should set, minimum guarantee that he has to set. So he has to set at this point. So from this point going. Okay, but the minimum should be here. So since we know that over here is 0 and from here to here is 0.5 and here is 5%, so we can get the value of from this to this. We can get from here to here, and from here to this place will give us 50% minus 5, so 50 minus 5, so we're having 45. Let's look at it very well. So we're having 45, yeah, so you have 50 minus 5, so you have 45%. So from this point to this point, you're having 45%. Okay, so that means he should set a minimum growth rate such that a given z-score will give him 45%. He has to set a minimum growth rate such that any given z-score of the value of the minimum growth rate, the z-score of the value of the minimum growth rate should give an area of 45% or 0.45. So now here we are having the area. Here we are having the area under the normal curve to be 0.45. That's the area we are having. Now we have to go backward to find the z. To find the z-score of this area. We have to go back to find the z-score that gave us this area. So what we do in this case, since we are having the area already, now we'll go to our z-score table. We'll go and look for under the area under the z-score. We're going to look for where we'll get any value close or equal to 0.45. The closest value to 0.45, then we'll find its z-score. So let's see if we can get closest value 0.54. So we have let's come here. So we have over here, you can see we have 0.4505. I have 0.4505 here. Now we trace it up, have 0.05, then come trace it this way, have 1.6. So if you add those two, 1.6 and 0.05, you have 1.65. So if we were given a z-score of 1.65, should give us the area 0.4505. So if we were having this to be a z-score, it will give us the area. But in this case, we were having the area, so we just went back to find the z-score. So just go back, look at the area under the normal distribution curve table, find 0.4505 and trace it up, okay, and then trace it to the extreme end row where you have the z-scores there, then get 1.65. Now remember, we are dealing with minimum. We are dealing with minimum value that we should set, and we had our 45 to be at the left side at this portion of the curve. So that means this value is actually negative. This value 1.65 is actually negative, right? So now we have our z-score. Now we are going back to find, the question says we should find the minimum value the farmer should set, the breeder should set, in order to get a minimum growth rate. So we have our z-score. Now going back to our formula, z says equal to x, which is the data. We want to find a z-score minus the mean divided by the population standard deviation. Okay, now remember we have our z right now, so minus 1.65 equal to x minus, now the question gave us the population, question gave us the mean and the standard deviation. It says it says initial growth rate reveal a mean growth rate of 19.5. If you recall the question, I hope you wrote it down. Said 19.5 is the mean the question gave us, and a standard deviation of 5.2. Standard deviation of 5.20. Now, if you look at the formula, you realize that we are interested in finding the x, because the x will give us the data which the farmer should set to obtain the minimum growth rate. To obtain a minimum growth rate not less than 5%. So you have this. If you should work this out, you obtain using the calculator, do some change of formula, we'll be getting okay, we'll be getting, where is the change of formula? Get 10.92 to obtain 10.92. So the 10.92 is the value that the farmer has to set. The farmer has to set a value of 10.92. Set that. So we have, let's go back, let's clean some of these things. So the farmer must set a value of 10.92. So this is the minimum growth rate that the farmer must set, such that he will not have any of the calves performing less than 5% growth rate. Less than 5% growth rate. So you should set this. So once you set this, you'll be performing more than 5% above, going up. Okay, so this is how to solve questions, problems that are normally distributed. Whenever a problem is normally distributed, must have your normal distribution curve. You find the z-score of whichever value you want to use to work on to find the area probability of any of the data occurring. And remember, we said that the probability of any of the data occurring is the same as the area under the normal distribution curve. Alright, so end the course here. Thank you very much. Please don't fail to subscribe if this is your first time of viewing. And when we come next, we'll be looking at analysis of variance. Alright, thank you. Yeah, ending here.